A cockroach is walking down a dirt path in Costa Rica. Not running, walking. Calmly. Voluntarily. It is heading toward a small burrow in the ground. Inside that burrow, a larva is waiting to eat it alive over the next 4 to 5 days. The cockroach knows the burrow is there. It can see it. It still walks in. 30 minutes ago, this cockroach had free will. Now it doesn't. The emerald cockroach wasp weighs less than a gram. It is smaller than your fingernail. And it performs brain surgery on live prey with a precision that neuroscientists have called, and this is their word, elegant. The wasp lands on the cockroach and stings it twice. Not randomly. 2 targeted injections into specific ganglia in the cockroach's brain. The first sting hits the thoracic ganglion. That's the nerve cluster that controls the front legs. The cockroach's legs buckle for about 3 minutes, just long enough. While the cockroach is temporarily unable to run, the wasp delivers the second sting. This one goes directly into a region of the brain that controls the escape reflex. The wasp finds it by probing with its stinger, using chemical receptors on the tip to locate the exact neural tissue. It takes less than a minute. The cockroach stands back up. It can walk, it can groom itself, it can eat, but it will never run again. The desire to flee has been surgically removed. The wasp grabs the cockroach by its antenna and leads it, like a dog on a leash, into the burrow. The cockroach follows. It does not resist. The wasp lays a single egg on the cockroach's abdomen and seals the burrow shut. Over the next week, the larva hatches and eats the cockroach from the inside out, carefully avoiding the vital organs to keep its meal alive as long as possible. Nature doesn't need committees or 3 drug protocols. It needs 1 gram and 2 stings. Dolphins are intelligent. You've heard that. You've probably seen the documentaries. The clicking, the playful jumps, the rescue stories. What the documentaries tend to leave out is the killing. In 1997, a marine biologist in Scotland documented a pod of bottlenose dolphins systematically attacking harbor porpoises. Not for food, not for territory. The porpoises were battered, thrown into the air, and drowned. Post-mortem examinations revealed broken ribs, punctured lungs, and massive internal hemorrhaging. The dolphins gained nothing from this. No calories, no advantage. Researchers have documented this behavior across populations in the UK, the Mediterranean, and the eastern United States. But the method that earned dolphins a spot in this video is something different. Male bottlenose dolphins form alliances, pairs, or trios that cooperate to isolate a female from her group. They herd her. They body slam her if she tries to leave. They keep this up for weeks. Marine biologists have a clinical term for this: coercive mate guarding. The rest of us have a different word for it. The point is not that dolphins are evil. They lack the hardware for moral reasoning. The point is that intelligence, in nature, does not produce ethics. It produces better strategies. Mr. Grimm looked into whether any animal has ever been observed showing genuine remorse after a kill. The scientific literature is very clear on this subject. No. You are snorkeling in the Philippines. The water is warm and shallow. You see a small, beautiful, cone-shaped shell on the sandy bottom. It looks like a collectible. You reach for it. You have about 4 seconds before the snail inside fires a harpoon into your hand. The harpoon is a modified radula tooth, hollow, barbed, and loaded with a cocktail of over 100 different toxins. Collectively, these toxins are called conotoxins. They target your nervous system with a specificity that pharmacologists have spent decades trying to replicate. One component blocks your sodium channels, another blocks calcium channels, another blocks potassium channels. Together, they shut down nerve signal transmission faster than any synthetic anesthetic ever created. Your hand goes numb, then your arm, then your diaphragm. The geographic cone snail's venom can paralyze a full-grown human in under 2 minutes. There is no antivenom. Treatment is mechanical ventilation. A machine breathes for you until the toxins wear off. If you are snorkeling alone in shallow water when this happens, the machine is not coming. 36 confirmed deaths, Probably more. The shell is still beautiful, though. A loggerhead shrike weighs about 50 grams. It looks like a songbird. It has a hooked beak, but its feet are not built for gripping prey the way a hawk's talons are. So it improvised. The shrike hunts insects, lizards, and small mice, catches them, and impales them on thorns, barbed wire fences, or sharp branches. It builds a pantry. Researchers have found single shrike territories with dozens of impaled prey items, beetles, grasshoppers, occasionally a small snake, mounted on thorns like a collection. The impaling serves two purposes. First, it anchors the prey so the shrike can tear it apart without talons. Second, it's a display. Males with larger pantries attract more mates. The shrike is, functionally, decorating its home with corpses to impress a date. Some toxins in the prey break down over time when exposed to sun, so the shrike is also using its pantry as a detox station, waiting for poisonous grasshoppers to become safe to eat. A brain surgeon that removes free will. An intelligent mammal that uses its intelligence for cruelty. A snail that fires a chemical weapon faster than you can pull your hand back. And a songbird that builds a gallery of the impaled. Every method was optimized over millions of years of natural selection. No committee, no protocol, no promise that it would be humane. Nature never made that promise, which, if you think about it, might be the more honest approach. Death by nature is worse, and more creative. But the most unsettling places on Earth aren't where animals hunt. They're where the ground itself swallows people whole, and nobody can explain why.